So for the image and video processing system, so let us begin with the introduction with digital image processing. In this module, we'll be focusing on two concepts, that is digital image processing and the fields that use this DIP, that is digital image processing. The definition, if they ask what is digital image processing, they might ask for the small definition in which will have the definition and the components used. You can just mention the components or the processes in it. Or if they might ask 7 marks or 10 marks, where you will have to explain the key points along with explaining the components. So definition is the digital image processing. It refers to manipulation of data images through a digital computer. So basically, you will be having a raw image and you just turn it into a meaningful image. So here, the digital image, whatever you acquire, usually you know, right, you acquire through like cameras, and so you manipulate those images in digital computer. What you do in that is specifically there are two dimensions here, x comma y. So here x comma y is x and y are the spatial coordinates, and f is the amplitude. In that sense, there are pixels, right? So each pixel is minute and dot, so that each thing is a coordinate. So wherever a pixel has, it has a specific coordinate. So that's what this f of x and y represent. It represents grace level, intensity, or the gray level of the image at that point. Those points are nothing but pixels. So you can also say that those of elements known as pixels. Then here there are the key points of this. What is a digital image? So a finite number of elements. See? So just you can also add this in the definition. It is just a finite number of elements, that is pixel, with specific locations and values. It will have its own different intensity or gray level. Then image processing using algorithm techniques to enhance manipulate image. Then applications, various fields are medical. This is nothing but the fields where this is used. So you can simply fill more than 5 to 10 places in this. Electromagnetic spectrum, imaging machines can operate across the entire electromagnetic spectrum unlike humans. So human visions cannot see properly each and everything, like all the waves. But this can see all the wavelengths, all the colors in the spectrum. Then continuum of processes, there are three levels here: low, mid, and high. Low is nothing for basic operation, noise reduction and contrast enhancement. Mid level involves segmentation, description, and classification. Segmentation is what for analyzing the image properly. So we just divide them into parts so that we can identify the objects and everything. High level processing is understanding and interpreting the content of the images, akin to in the sense which is understandable by the human vision. Usually, this is used in all the AI models. Then here is the component: input device, processing unit, and output device software. All you can see, camera scanners are nothing but input devices. You need a digital computer or specialized hardware. So remember that processing and all is nothing but, see, if your devices are there, that is different. Applications are different. Algorithms and applications are used to process the image, but processing unit is nothing but the actual hardware. Okay, digital computer hardware. So you can see a mobile also can come under this. Then conclusion, here you can simply read this conclusion and question your questions. You can see here like what kind of questions can be asked, since they have not asked any questions, right? Nor neither they have given any model. So this is the questions. We'll move for the examples of field that use digital image and processing. So firstly, we have medical imaging. Before that, we'll see here the DIP has a vast interval. So first, before every time writing the fields, you just have to write it has a of significantly impacting technology and society. This have to write key. It is widely used in many places and it has very importance. Let us start explaining how it is applied or utilized like that, and then simply start. So here we have four types of imaging in under medical imaging: gamma, X-ray, computer tomography, and microresonance imaging. So gamma ray is nothing but for what to say. Usually, I'll just explain you the what to say basic part, like important part. We can easily elaborate it. So here, what happened? A radio wave isotope is injected to the human, which will emit the gamma rays, and these gamma rays are captured and studied. So it will allow you to read the interval, visualize the internal structures, can detect the bone pathologies, and it is used for the nuclear medicines. Then X-ray, but you can simply write it is used for what to say medical diagnosis. It helps to visualize the internal of the body. And you can also see uses mostly used when to treat for fractures, to identify fractures in the CT is nothing but it produces a cross-sectional image of the body. So 3D. Remember, it allows the 3D reconstruction of the organ or tissue. I mean, of the part wherever you are seeing in the inside the body. So this is very used in medical studies for doctors and researchers to like get proper the human body and understand its physiology. Then magnetic resonance imaging, that is MRI, it uses two and magnetic waves. So it creates a detailed image of the organs or tissues inside the body, and main use to say to study the brain, spine, and joints. So that was only medical, and this is industrial. So I'll just tell the what to say basic part. I won't be reading everything and explaining. Control is nothing but whenever something is manufactured in the factories, right? So those machines will be what to say keep on doing the work. So like a series of this flow will be there from the it will be keep on moving, and so many things will be created at that time. So they have taken the example of circuit board. So in circuit board, many components are there. So it passes through a place where the DIP is there. It sees all the parts of the circuit board. If anything is missing, it will identify and give the alert. So that is what we call non-destructive testing. Is nothing but in the airports, we usually see that our bags have been sent into under some kind of what to say like curtains type of things, black, and it just scans everything, sends out. So it just uses to like X-ray type of rays to detect everything inside that actual carriage and luggages to just check whether it is containing any destructive things or not. Remote sensing, nothing but satellite and weather forecasting. So this is used for satellite imaging. For example, it is how to say in the images are captured by various spectral band to understand the agriculture development, urban development, and environmental changes, and weather forecasting nothing but multispectral imaging from satellites. So satellites can have that imaging, right? So they have a proper technology to a place and what to say read everything, like capture everything, like camera type things. So they can easily see the pattern of clouds, water, like you know that hurricane and all. In the picture, it shows yellow color, red color, and like a circle thing in movies or things. So that's nothing but weather forecasting. Astronomy, so gamma ray astronomy and X-ray astronomy for observation of celestial phenomena like supernova. So for basically these both are used for higher energy events, to study high energy events. X-ray astronomy is nothing but telescope read or study to visualize far objects and what to say and understand, like for example you can uh, neuron stars and other things and all properties and behavior. So all these things are used under this activity and surveillance. Facial recognitions, so in any malls or anywhere like, for high security, so facial recognition are useful for license plate recognition for your bikes, for traffic cameras where they if you break any rule it captures your for picture of license. And scientific research is nothing but fluorescent microscopy and electron microscopy. Here biological research for studying cellular structures, and electron to study the things at the nanotechnology or atomic level space. So here cellular structure is nothing but complete cell. Cell can also be divided into like very small one, that is atomic level. So atoms, right? So atoms constitute everything. Then media, computer graphics and image enhancement. So computer graphics is nothing but your YouTube videos and games. And enhancement is nothing but the way what to say you take pictures in DSLR and edit it, modify it to clear the blurs and everything. Usually in photo studio. Then this is the conclusion. Key points for all the 7 fields here. Fields can also be added here. You can simply see and write for. You can simply specify or classify into different parts and still elaborate all this. Then here are the questions, all the things which can be asked.